Pixels. They're the stuff old games are made of, right? Actually, they make up everything you see on any modern, versatile electronic device designed to show different pieces of information using the same output mechanism. In other words, screens. But how do screens work? Imagine you're reading a piece of paper. Your eyes gravitate towards the upper left-hand corner of the page and start scanning rightwards, processing each word as it comes, stopping when you reach the edge of the paper and moving on to the next line. You do that until you've reached the end of the text or you've reached the end of the page, at which point you move onwards to the next page. Well, screens are very much like that, except they're a lot faster than human perception. This methodical process of moving across the screen is known as a raster scan. On a physical level, output to a screen requires at least 3 signals be passed. There's the intensity, the line sync, and the frame sync. Sync is short for synchronization, the act of making sure things are in order. The intensity controls the brightness of the pixel given by the current position of the raster scan. For simple color output, there are 3 separate intensity signals instead of just one: red, green, and blue, from which all other colors of light can be derived if you're smart about it. The line sync is a digital signal, 1 or 0. It only goes high, 1, when the device wants to let the screen know when we're starting a new line so it can jump there. The frame sync is similar, but instead of jumping to a new line, it jumps all the way back to the top left-hand corner to start a new frame. You might have noticed that the device isn't sending actual positional information, just various relative measures. That's because the job of performing the raster scan is typically given to the hardware dedicated to the screen itself, counting along and only being affected by the device when they're out of sync. How quick does this happen? Typically, you want to get at least 25 frames per second because that's around the limit of human perception. Anything faster than that ends up feeling nice and smooth but isn't actually needed. So, now I've introduced you to how the raster scan is used to enable video output to a screen, whilst using one. Amazing.